Alright, in today's quick vid, we're just going to quickly review some of the concepts from yesterday, as well as just taking a look at some equations and seeing if we can inspect them visually in order to determine if there's one solution, no solution, or an infinite amount of solutions. So just to quickly review, because these are important concepts, if something has one solution, okay, in an equation you would end up with something like a variable equals a number, like x equals 8, or y equals negative 2. In the graph, as we saw yesterday, it's when two lines just find an intersecting point on the graph. So they only intersect one time, so there is only one solution to that system of linear equations. Okay, so if we want to take a look at something that has no solutions, that's when you have something like the following, something that doesn't make sense, like 7 equals 9, or negative 3 equals 4, where you have two numbers that don't match up and that don't make sense. And on a graph, we can see that as the following, when you have two parallel lines that don't touch each other. Okay, so in this graph here, we know that these lines have the same slope, but what do you notice about the y-intercepts? The y-intercepts are different, so that's going to help us out later on. Okay, and then finally, infinite solutions. Infinite solutions are when you have an equation, you end up getting something like 4 equals 4, or end up with like negative 1/2 equals negative 1/2. When the left side equals the right side, that's when you have an infinite solutions. And on a graph, that would look like the following. And let me redo that actually. Let's try it differently. It would look like that. Okay? So you have one line. And the reason why you have one line is because both equations have the same y-intercept as well as the same slope. So they're going to be right on top of each other. Notice here they have the same slope but different y-intercepts. And then notice here they have different slopes. So those are some of the things to think about as we move forward in today's quick lesson. So down below in section 1 we have 4 different problems. And what I'd like you to do is just try to identify what the solution is. Is it one solution, no solution, or infinite solution? So again, if it's one solution, they're going to have different slopes. If it's no solution, they're going to have the same slope, but different y-intercepts. An infinite solution is same slope, same y-intercept. So let me just quickly jot that down. Hang on. Okay, so I just quickly jotted down and abbreviated. You can see here one solution will have different slopes. If I have no solution, it's going to have the same slope, but different y-intercepts. And if it's going to be infinite solutions, it's going to have the same slope and the same y-intercept. So if you want to quickly jot that down, a guide to help you, that'll work out. Okay, so let's take a look at the first equation here. 3x plus 2y equals 5, 3x plus 2y equals 6. Okay, now this one I can identify fairly quickly that this is going to be a no solution, that this doesn't make sense. And the reason why is the following. Look at the left of both equations. 3x plus 2y. So here I've got 3x plus 2y equaling 5. And in this equation, I have 3x plus 2y equaling 6. Okay, that doesn't make sense. I can't have the left side be exactly the same, but getting different right side answers. So in this case, this would be no solution. Okay, now I could go through and put it in slope-intercept form and look at the slopes and y-intercepts, but when I look at this one quickly, I can eyeball it. Again, the left side, 3x plus 2y equals 5. Here, the 3x plus 2y equals 6. That doesn't make sense. Okay, that would be like saying x equals 5 on this side, x equals 6 over here. And it just doesn't make sense. Okay, so take a look at the next one. So here we have y equals 3x plus 4 and y equals 3x plus 12. Well, what I want to do is I just want to expand or distribute this 3. So multiply your 3 by everything on the inside. So that new equation is going to be y equals 3x plus 12. Well, what do you notice about the slopes? Well, the slopes are the same. What do you notice about the y-intercept? The y-intercepts are the same. So in this case, you would have infinite solutions. So I did a little manipulation of the equation to put it in slope-intercept form to figure out the slope and the y-intercept, and then I can compare the two. Okay, take a look at the next one. Okay, now the nice thing about this one is they are already in slope-intercept form. So when I look at this first one, what is the slope? Well, the slope's 1/2. What is the slope of the second equation? Well, the slope of the second equation is -3. Well, if they have different slopes, and I know they're linear, well, then I know it just can only be one solution. One solution. Because, again, they have different slopes. Here it's -3, here it's 1/2, so at some point they're going to intersect. Okay, now the next one, y equals 2x minus 4, and y equals 2x plus 3. Well, let's take a look at the slopes. Slope of this one, m equals 2. Slope of this one, m equals 2. Okay, well, I have the same slope. Well, now what's the y-intercept? Well, y-intercept here is -4. Here the y-intercept is 3. I have different y-intercepts. So this one is going to be like, I'm just quickly sketching. I don't know what it's actually going to look like. Okay? So something like that, where I have the same slope, but different y-intercepts. So this one then would be no solutions. No solution. Okay, now on the bottom of the page I have 2 word problems. Now I'm not asking you to find a solution. All I want you to do is to figure out, is it one solution, no solution, or infinite solutions? So the first one says the sum of 2 numbers is 100. So what I would do in this case is I would simply type, or not type, but write x plus y equals 100. Well, there I have the sum of 2 numbers, x plus y. I know it's going to be equal to 100. So that's this first part. The second statement says twice the first number plus twice the second number is 200. Well, how would I write that down? Well, I would write twice the first number, so 2x, plus twice the second number, that's 2y, equals 200. Okay? So now, is this a one solution, no solution, or infinite solution? So you can manipulate the equation to put it into y equals mx plus b, take a look at the slopes. But one of the things I notice here, and again I'm just trying to shorten this up a little bit, is I notice everything here is kind of a multiple of 2. So what I'm going to do is divide everything by 2. And it doesn't change the value of the equation because I'm dividing everything by 2. Well, when I do that, that becomes x plus y, and then finally 200 divided by 2 is 100. And when I do that, I can now compare these 2 equations. So what do you notice? They're the same exact equation. Okay? So in this case, it would be infinite solutions. And to prove that, just to show what I mean, again, I'm not looking for solutions here. It says the sum of 2 numbers is 100. Well, give me 2 numbers. How about 25 and 75? Well, 25 and 75 is 100, right? Well, now what happens if I double both of those numbers? Do I get 200? Well, let's see here. 2 times 25 is 50. And 2 times 75, 2 times 75 is 150. 50 plus 150 is, in fact, 200. So you can see that works. I could use any 2 numbers. What about, well, you can just choose any 2 numbers that up to 100. It'll work again for the second equation. See, that's how you can tell that there are infinite amount of solutions. There are more than one. Okay, and finally, the last one. A customer bought 6 cups of coffee and 4 bagels and paid $10. So let's write an equation for that situation. So 6 cups plus 4 bagels. I wonder if it's an everything bagel, or a sesame seed bagel, or an Asiago bagel. I'll take any one of those, thank you. Equals $10. Okay, so there's my first equation. Then another customer purchased the following. Okay, so they bought 3 cups and 2 bagels and paid $15. Okay, so take a look at these 2 equations, and it doesn't seem like there's any way to manipulate them other than to put them into slope-intercept form. So I just need to solve for one equation, then compare their slopes here. Okay, so I'm going to subtract 4b from both sides. Minus 4b. So that gives me 6c equals 10 minus 4b. Then I'm going to divide both sides by c. So c equals 10 over 6 minus 4 over 6b. So let's compare that slope and that y-intercept to the other equation. So here I'm going to subtract 2b from both sides, minus 2b. That's going to give me 3c equals 15 minus 2b. Divide by 3. That gives me c equals 5 minus 2/3 b. Okay, so take a look at this one. Now what I notice is here the y-intercepts are different. Here's 5, here's 10 over 6, but the slopes are exactly the same. So negative 2/3 here and negative 2/3 here. So the slopes are the same, but they have different y-intercepts. That means in this case there is no solution because I have the same slope but different y-intercepts. Okay. All right, so what I'd like you to do is go ahead and try the back page on your own, see what you come up with. The answer key is already there. I'm going to move the video along so you can see the answer key. If you have any questions, again, ask one of your teachers. So go ahead at this point in time, go ahead and hit pause, and then when you're ready to check your answers, go ahead and hit play again. Okay, go ahead and hit pause, and you can see the bottom.